All right, so Unit 2 study guide. So back in Unit 2 there, this one, by the way, was all about powers, right? Everything to do with exponents. Let's just kind of go through like a few of these different skills that, like, this was really the unit in a nutshell, right? So the first one, so evaluate a power with an integer base. Okay, so this would have been, I'll just give you some examples here. Anything like the one there was, -2 to the power of 3. And the big part of what you guys need to know is, what does that actually mean? Like, what does that exponent at the top do? The biggest mistake people make is they go, okay, -2 times 3, right? They do that quite often, but that's not what exponents are. Exponents are this base, this -2 to the power of 3 means like -2 times -2 times -2, right? 3 times. So that'd be the same thing as this, right? -2 times -2 times -2, which is -8. Now, careful, because this is always the most confusing part. I almost feel like I need to figure this out in math because it confuses kids so often. -2 to the power of 3 and -2 to the power of 3. Actually, it's a bad example because they end up being the same. But let's just go squared to keep things same. Okay. If I look at those two answers, those actually give me two entirely different answers, right? Because they mean different things. The first one is this, right? That actually means -2 times -2, right? So what would that be? Negative times a negative, that would be 4, right? +4, because negative times negative gives you a positive. Now, the other one here, -2 squared without the brackets, that means something different. That negative is just like tacked on the front. This would be the same thing if the brackets were right there. They would, now the squared part of this, or the exponent, is only applying to the 2, not the negative as well. So this would actually be written like this. It'd be negative and then like 2 times 2, which would be, again, the negative is just tacked on the front, or you can think of it this way too. It's like -2 times +2. Either way, this would turn out to be -4. +4 and -4, even though they look like they're like similar answers, those are completely different numbers, right? So if you get that wrong, then the entire question's wrong. Okay, so just careful on those guys. It's probably the number one place I think in this unit that kids make mistakes, right? Because it's easy. Like, I even understand that's a hard thing to recognize, but just try to pay attention as much as you can to those brackets. Okay. So next one. I don't know why I erased that. I shouldn't have erased that. The next one here, anything to the power of 0 is 1. So careful on this on the assessment. I might have thrown some things in there. We're just trying to see if you know this one. So if I had anything, right, let's say like 2x over 4 plus 5 to the power of 57, minus 2, all to the power of 0, that whole thing, I'm not going to start doing the math on that. Doesn't really matter. All of it is equal to 1. Okay, so just keep an eye open for those guys. Now, using orders of operations. You know what? I think for these ones, the best way to do it, you guys can look back on these ones. I'm going to do some examples. I think it'll help you, but we just got to make sure we use our order of operations for exponents. And then remember your power laws. So if you are multiplying with the same base, they have to be the same base. Multiplying, what you do, you add the exponents, right? So 4 to the power of 3 times 4 to the power of 6 would be the same thing as 4 to the power of 3 plus 6, right? You just add those exponents to be 9. Okay, that's called the product of powers. Now, quotient of powers, or dividing, right? Quotient means dividing. So very similar. If you're dividing powers, so like this with a division symbol, or over, they mean the same thing, then you subtract those exponents. Okay, the next one, if you've got a power to a power, we multiply. And then the other one was that you can rewrite, if you've got anything like 6 times 3 to the power of 5, then you can think about that 5 as being applied to both of those things. So you can distribute that power on there. And then the other one that we do quite often, if you've got something like 5 over 2 to the power of 2, same thing. You can just apply it to both of those. That'd be the same thing as 5 over 2 over 2 over 2. Okay, but those are different bases, so I can't like subtract those or anything like that now, right? All right, so That's the whole unit in a nutshell. So let's just do some examples here. So I'm just going to bring up a couple. Let's do one like this. So say like number 1. What would this be? -2 times -2 times -2. That whole thing could be rewritten as -2 to the power of 3, right? Just because there's 1, 2, 3 of them. And that's it, right? All right. Number 2. Let's say we had -2 times 2 times 2. How would we write that one out? All right, so this part here, this 2 times 2 times 2, I'm just going to treat that on its own. And remember, even the way this looks, there's no brackets here. That negative is just like tacked on the front, right? So I'm just going to leave that out there. It's going to come along for the ride. That negative will just be down below. And then this part here, this is 2 times 2 times 2. That is 2 to the power of 3. And if you put this one and this one into your calculator, they would actually end up being the same, right? They both be negative because you've got, an odd number exponent, right? All right, let's go number 3. So let's do 5 to the power of 0. This will be a quick one. That is 1, right? Anything to the power of 0 is 1. Okay, let's do this one. Let's say we had 3 to the power of 4 over 3 to the power of 2. Okay, so now you could put both that in your calculator, right, and get the answer, but we should be able to do these ones with our calculator, especially this one. So what do we do if we are dividing? If we got the same base, right, base 3 and the exponents, and we're dividing them, what do we do with the exponents here? We subtract when we're dividing, right? So this would be the same thing as 3 to the power of, and then 4 minus 2, that's 2. Well, I can do that one in my head. 3 squared, that's 9. Okay, let's do one like this. Let's say we've got a to the power of 3 times a to the power of 5 over, here, sorry, my brackets are a little funny here, over a to the power of 2 to the power of 3. Let's do one like that. All right, now, there actually is no right way to do this one. There's an easier way and a harder way, I think. You could, if you wanted to, like apply that 3 to everything in the inside and then deal with it then. But it's actually gonna be a little easier just to figure out this middle part first and then go that number to the power of 3, right? That'll be a little easier here. So let's do that. And to start off, I'm gonna do just the top. I'm gonna do step by step. So just the top here. So we've got a to the power of 3 times a to the power of 5. What do we do with those when we are multiplying? So we've got a to the power of, I was multiplying those, so I add the bases, right? So that's going to be a to the power of 8 over a to the power of 2. And that's still all to the power of 3. Okay, so now I'm going to go a to the power of 8 divided by a to the power of 2, like just doing the inside here. That's going to be the same thing as a to the power of 8 minus 2, so that's a to the power of 6. To the power of 3 still. Okay, and then very last thing, what do I do when you're going a power to a power? Well, we multiply, right? So this is going to be 6 times 3. This would be a to the power of 18. All right, I'm going to start up here again. What was that? It was 5. So we'll go 6. Okay. What else do we got here? Let's go. let's go 3 over 2 squared. And it says, and maybe it says, write this as a fraction, right? Like keep it as a fraction. All right, so what the idea here is you just need to know that this 2 is being applied to both of them, right? The squared. So this would be like 3 to the power of 2 over 2 to the power of 2. That would be 3 to the power of 2 is 9 over 4. All right, should we start doing some harder ones? Let's make them really funny. All right, let's do one like this. So we'll say n squared to the power of 3 over n to the power of 3. So all in brackets. And then I'll say that times n to the power of 4 times n to the power of 3 divided by n to the power of 2. So that's a mess. Looks complicated. But really, it's not any harder. We just need to do it like just step. There's just more steps, right? It's all the same stuff we've been doing. So let's do this one first. So looking in here, like according to BEDMAS, I want to do inside the brackets first. Okay. Some of you guys are getting ahead of me here. All right, so let's go n to the power. So this first one here, right? So we want to do inside the brackets. And I'm going to do the top here first, right? Because that really is like it's in brackets, right? It's all over this one. So I'm going to get rid of that one first here. So that'll be n to the power of 2 to the power of 3. That's really n to the power of 2 times 3, right? With the exponents there. So that's going to be n to the power of 6 over, and then I'll just write it all again. N to the power of 3. And then here, we'll do lots of steps here. I could combine these right now too, if you guys are all right with that, because it's all inside the brackets. Okay, let's do that. Let's actually just do that. It'll make life a lot easier. So here we've got n to the 4 times n to the 3 divided by n to the 2. All right, we could do all of this in one move, because with BEDMAS, it doesn't actually matter about the order that you do these things in. Technically, just in your calculator to avoid making mistakes here, it's actually a little better if you do the multiplying before the division. But it doesn't actually matter which order that you do those things in if you're doing it right with brackets. But I'm going to do it all in one move here. I'm going to go. Let's go n to the 4 times n to the 3. Then we add, right? So that's going to be 7. Oh, I did a bad number here. This is not going to work out nice. Let's go. I'm going to make that a 4 too. Sorry, guys, if that messed you up. You just would have got like a half of exponent. I don't want to get into that. So n to the 4 times n to the 4, that's n to the 8. Well, sorry, no, you wouldn't. What am I doing? Sorry. I screwed myself up. Yeah, 4 plus 3 is 7. Minus 2 is going to be 5, right? So that would all be the same thing as n to the 5. Okay, we're getting there. Let's do the division one here now. So n to the 6 over n to the 3, that's like 6 minus 3. So that's going to be n to the power of 3 times n to the power of 5. And then, yes, Blaine, you were right. You add those now. So this is going to be n to the power of 8. Okay. Let's do a tricky little one with our brackets. So let's say we had this. Let's say we had -1 squared times -1 to the power of 6 minus 2 divided by, we'll say -1 to the power of 5. This is where you can like make little mistakes, right? It's a little tricky here. It's actually a little annoying whoever came up with this question, because that's a bad way to write it. but but here's what we got going on. So order of operations, right? So let's write down BEDMAS to begin with here, just so we don't mess this one up. Okay, so brackets first. Okay, so what we could do with brackets first here, like brackets in the exponents part, let's figure out what this actually is, right? Because we don't need to keep those brackets and everything else. And we can figure out what this one is. And we can figure out what this one is. We'll just make life a lot easier. So I'll just go left to right with everything, all those brackets and exponents. So -1 squared. All right, so -1 in brackets, the way it's written there, right? That's going to be the same thing as like -1 times -1, right? Negative times a negative, that's going to be a positive. Any even exponent would always come out to a positive. An odd one, written like this with a negative, would come out negative, right? So this is going to be just 1, right? 1, like +1 times. Now, what about this one? And again, careful with the brackets here, right? Because they look different. This one doesn't have those brackets like that, right? This one just has that negative tacked on the front, and then it's 1 to the power of 6. So 1 to the power of 6 is just 1, but we've still got that negative hanging out there. So this is still -1. Okay, and then -2, just stays the same. And I'm just going to write this again, divided by, and then -1 to the power of 5, that's really -1. Okay, now, so we've got that. We got rid of all the exponents. Now we just got to make sure we do this in the right order. So it's division and multiplication. So division and multiplication, I'm going to do the multiplication part. And then, so because that's 1 times -1, right, is what's really going on there. And if you wanted to, you could even put brackets there just to make sure that we're doing this right? So that's like 1 times -1. And then this next part here is minus, and then it's 2 divided by -1. So that's like in brackets there, right? 2 divided by -1. I just put the brackets there just to make it a little bit more clear for me, like when I'm doing it here. Okay, so 1 times -1, or that's going to be just -1, right? Positive times a negative. And then minus 2 divided by -1, that is -2. And again, I'm going to put a bracket there just so it makes more sense to me. All right, we're getting there. Now we've got -1 minus a negative. So what do you get if you go minus a negative? That's the same as adding 2, right? Minus a negative is like +2. So -1 plus 2, that's 1. All right. It doesn't get much more tricky than that, right? Those are kind of annoying. So just on those ones, there's a couple of those on the assessment there. Just try to be really careful because I know that's so easy to get messed up on those ones. But yeah. Do you guys have any other questions?